DevOps as a field has changed more in the past 3 years than in the previous 10. And the role itself has split into multiple distinct levels. With each level, you have different responsibilities, different skill set, and even different salaries. Hi, I'm Vishakha, an AI solutions architect, and today in this video, I'll be walking you through 7 distinct levels of DevOps. For each level, I'll tell you the role names that you'll see in the job listings, the skills you actually need, the certifications worth pursuing, what a day in the life looks like, and the salary ranges so that it'll motivate you to work a little harder. By the end of this video, you will know exactly what level you are at, what the next level requires, and the kind of compensation you should be targeting. Let's get into it. Level 1, the entry point. This is where everyone starts. You're 0 to 1 year into your career. You're either straight out of college, switching from software engineering, or even coming from a non-IT background, trying to break into tech. Now, traditionally, DevOps always revolved around software, but now things have changed and now it revolves around both software and AI applications. Now, to start with, you need to be familiar with the whole software engineering life cycle, where software engineers basically come in. They get the requirements, do the designing, implement it as a code, and then DevOps takes it further. The key differentiation you must know is around how software engineers are different from DevOps engineers. Software engineers on one hand focus on gathering requirements, taking design decisions, implementing that application using code. And DevOps on the other hand takes it further, deploying those applications on servers, operating the whole infrastructure where the code runs, monitor services, automate repetitive tasks. Now that is a core essence of a DevOps engineer. The role names that you must target is DevOps trainee, junior DevOps engineer, cloud support associate, or cloud operations engineer. What are the skills you need? Number 1, coding skills. Coding skills are not a must, but as you go up the ladder, it changes. Also, DSA is not a hardcore requirement for DevOps. It is not a must-have skill, but good to have skill, and depends on companies if they are really hiring engineers with coding knowledge. Again, this is not under your control, so if I were in your shoes, I would have some knowledge around Python or Java, basic to intermediate level. Now let me tell you what skills you must have. So you start with becoming comfortable with either Linux or Windows shell environment, and then you gradually learn how to automate things that you used to do manually. Logging into a server, restarting services, inspecting logs, debugging deployments. So the thing you learn here is how to automate a repetitive task using either a coding language like Python or Bash scripts. Now you dive into the software development and deployment part. Make yourself very familiar with Git. How does branching, merging, pull request works? How do you push code? How do you open a pull request or review a request? This is essential. Once that's done, pick a cloud and understand what are different service models, what are different deployment models, and then dive into the core services. You should understand concepts like DNS, HTTP versus HTTPS, REST APIs, load balancers, Nginx, compute instances, storage, and how deployment works. This includes understanding how a URL works, how DNS resolves it to an IP address, and how requests and data move between services. You should also know basics around reverse proxies, caching, ports, SSL TLS protocols, and how traffic flows between these backend servers. Now in this level, you don't really need deep expertise in distributed systems. We are not there yet, but you should be comfortable debugging basic connectivity and deployment issues. Now in 2026, AI tools exposure is also expected. This means using tools like GitHub Copilot, Claude Code, Codex, and use them to debug scripts, understand logs, and generate that automation pipeline you used to do manually. So you're automating the automation here with intelligence. Another key requirement that you won't get in any other videos right now is being good at understanding AI system flow at a high level. How prompts go to a model, how does API connects these systems, how does model generate responses, and what's the infrastructure that's serving those requests. Again, having a high level knowledge is good enough in this level. You must understand different system design concepts as well, like distributed systems, monolithic versus microservices. How does load balancing works? Now, certifications to target here. Start with a cloud practitioner certification. It could be AWS Cloud Practitioner or GCP Digital Leader, any practitioner level. The essence here is to be familiar with the cloud core services. Now, thing to note, it's not a requirement. You can skip the certification altogether, but the reason certification course might help or a certification learning path might help is because they provide a very structured roadmap and they give you the modules where you learn about certain concepts and there are questions where you are tested, so you retain those things. A day in the life of junior DevOps trainee or engineer means responding to the tickets, debugging deployments, checking logs, provisioning IAM access, and writing small automation scripts using AI tools. Here are the salary ranges that you can target. Let's jump into level 2, and now you're operating cloud infrastructure at real scale. Here you are 2 to 4 years into your career. You're just not writing some automation script or running cron jobs for backups. You are building distributed, scalable systems that engineering teams depends on. The role names here are DevOps engineer, cloud engineer, technical solutions engineer, build and release engineer, or infrastructure engineer. In this particular level, you're not just building skills, but you're also becoming very familiar to certain tools. You understand the whole CI/CD pipelines and how it runs with either GitHub Actions or Jenkins. What's the full DevOps stack within a cloud provider? For instance, AWS has CI/CD with code pipeline, code build, code deploy. GCP has a different stack with Cloud Build. Azure has a different stack with Azure DevOps. Next, you must be familiar with one ISC tool. It either could be the most popular one, Terraform, or it could be specific to a cloud provider such as AWS CloudFormation. Pulumi is also gaining a lot of popularity, so you may see it in a bunch of job listings as well. And if you're building skills with Pulumi, you must be familiar with one programming language, such as Python, TypeScript, Go, or Java. Traditionally, there were also requirements around being familiar with configuration management tools like Ansible, Puppet, Chef. So if you have that knowledge, it's pretty good because a lot of enterprises still work with those configuration management tools. This is also the level where architectural thinking starts, whether you should use cloud managed SQL database versus self-managed SQL database. What would be the trade-offs? There'll be meetings where you'll have to discuss these design decisions out loud. So for that, you need to understand system design and the trade-offs. So make sure you're diving into those concepts, different API types, different caching strategies, how does load balancing work, different load balancing algorithms, CDN versus edge, how does CDN works. You're expected to understand scalability, reliability, and cost trade-offs here. Now, AI infrastructure expectations also begin here. You must understand how GPU workloads are different from traditional software workloads. What are the different performance metrics with models? And the basics of deploying AI APIs or model-backed systems inside cloud. Make sure you also dive into containers, how Docker works, how do you write Docker file, why do we really need Kubernetes. Key certifications to target here. Now you can focus on ISC-based certifications like Terraform Associate or cloud-specific professional certifications or DevOps-specific specialty certifications within cloud providers. A day in the life in this level means building pipelines, reviewing Terraform changes, approving it or rejecting it, debugging CI failures, supporting production deployments, thinking around different strategies of deployments, and mentoring junior engineers. These are the salary ranges you must target. Now let's enter level 3. This is where things are getting advanced. You're 5 to 8 years into your career and you stop thinking around servers and start thinking in workloads. A lot of your life revolves around clusters, auto-scaling strategies, distributed workloads. The roles you must target here is senior DevOps engineer, Kubernetes engineer, cloud native engineer, technical account manager, platform engineer. Here you need a bit of advanced knowledge around everything that you have built in level 1 and level 2. So you dive deeper into containerization. Now, when I say deeper Kubernetes knowledge, it means not just sticking to the core objects, but how different scaling strategies work. What's HPA, VPA, KEDA, like Kubernetes event-driven scaling? How can you write your own controllers? How does operator works? How to set up persistent volumes with remote storage? Advanced scheduling behavior. You should get familiar with Helm, Customize, and at least one service mesh like Istio or Linkerd. Within the workload space, you must understand that there are different tools that manage and solve different problems. Kubernetes is the de facto platform for enterprises, but there are also cluster management systems like Slurm. So make sure you understand the difference between Slurm and Kubernetes. Observability also becomes critical here. You must be familiar with one full stack. Rather it be Prometheus for collecting metrics, Grafana for visualizing through dashboards, OpenTelemetry for collecting traces. In this particular level, you need a lot of experience correlating logs, metrics, and traces because you will be called to debug real production failures. And as you grow through this level, you collect a lot of gotchas. For example, a broken readiness probe can remove healthy containers from the cluster. Bad memory limits can trigger kill event. If you misconfigure horizontal pod autoscale up policy, it can overload nodes. DNS failures and understanding how networking plays such an important role in debugging distributed systems. It's always networking. Now in this level, you just don't understand AI infrastructure. You need to operate it. You must understand GPU scheduling basics, model serving workloads, batch versus real-time inference patterns, and how AI workloads stress Kubernetes differently from traditional applications. Now, certifications to target. You can take one Kubernetes-based certification, either CKAD or CKA, and then if you want to level up further with security, take CKS. And to dive into AI infra, you can also take NVIDIA's AI Infrastructure and Operations Associate certification. It's pretty good. A day in the life means production debugging, incident response, cluster tuning, observability work, and reviewing infrastructure changes from other engineers. These are the salary ranges that you can target. Now, level 4 is where your mental model changes completely. The roles you'll target here are staff DevOps engineer, GitOps engineer, lead cloud engineer, customer engineer, Infrastructure architect. The goal of this level is consistency and standardization, which basically means you're building reusable infrastructure patterns that dozens of other engineering teams can build upon. Writing modules, designing the architecture, gateway level, infrastructure level, writing Helm charts, understanding multi-cluster and multi-region patterns. The skills here is a bit advanced on the previous level, so you're building and managing GitOps workflows, taking care of state management with Terraform, optimizing your container images so that you have lesser cold start times, distributing workloads across different compute types, containers versus serverless, keeping a very close eye at cost because that's what you will be doing a lot in this role. Cost analysis of your services so that you can lower the bill. You will also dive a lot into security here. Policy enforcement within Kubernetes using OPA Gatekeeper, and setting up network policies, enabling eBPF with your CNI plugins. You'll also spend a lot of time around the delivery side. How should you roll out your newer version, canary deployments versus blue-green deployments versus rolling updates, and also how you can roll back quickly. In this layer, AI deployment patterns also become very important. This means separating infrastructure for training and inference workloads, designing scalable deployment workflows for AI services, and how you can integrate AI system into your platform, like such as calling an AI API. Now, certifications to target here. You can pair a cloud-based certification with a tool-based certification in this level. Either go for Terraform Associate, GitOps Associate, Kubernetes certifications, and then complement it with a cloud-based specialty certification. For AI infrastructure, you can do professional level AI infrastructure and operation certification. Now, a day in the life here means architecture reviews, platform standardization, creating reusable modules, state management, running proof of concepts because you will be more customer facing in this level, also designing reusable deployment patterns. These are the salary ranges that you can target. Now, level 5 is where the role transforms. You're no longer the person manually operating the infrastructure. You're building the internal platform other engineers use to operate infrastructure themselves. The role names here are staff SRE, platform engineering lead, principal DevOps engineer, or solutions architect. Now, before we dive in, the goal of platform engineering is that application teams should be able to deploy software on their own without needing to understand all the Kubernetes internals. The skills needed here are internal developer platforms like Backstage or Port, self-serving infrastructure using Crossplane. Crossplane is also an ISC tool. Writing reusable and custom Terraform modules. Custom is the keyword. Being very familiar with deep SRE concepts like SLO, SLI, SLA, defining error budgets, setting up the whole incident response design, and the most important, capacity planning, because capacity is very important now. You should also be able to understand chaos engineering, which means intentionally introducing failures just to test how resilient your system is. So in this particular level, when you're preparing, you should review a bunch of case studies like Netflix case study, Snapchat case study, how they are deploying such scalable applications, and what are the best practices they are using for their architecture. This is also the level where AIOps becomes real. You should understand AI agents for operational workflows, alert triaging, automated remediation, and AI-assisted debugging systems, just like how we deployed Kira in our previous AIOps project. Link in the description below. If you're preparing for this level, you need to understand how engineering teams safely integrates LLM APIs into their internal tools. If you're calling Gemini API or calling OpenAI API, how does this tool calling work? Now, the certifications to target in this particular level. There are advanced AI infrastructure certifications from NVIDIA that you must check out. Then there are these cloud professional certifications you can target. A day in life means platform reviews, improving developer workflows, doing a lot of reliability engineering, and then on-call ownership. Level 6 is where DevOps engineers not only understand AI workflows, but they are also deploying those AI workflows. It is also called AI deployment engineering. Your job is to help companies to deploy AI systems into real production environments. The role name here are forward deployed engineer, applied AI engineer, AI solutions architect, customer engineering lead, principal architect, or senior deployment engineer. This level combines almost everything from level 1 through level 5. You need strong everything, strong cloud knowledge, strong Kubernetes knowledge, CI/CD infrastructure as code, and the most important, be able to apply it in the AI infrastructure environment. You should understand model serving, how RAG system works, what are the different backend engines like VLM, TensorRT, or SGLang, be familiar with agent workflows, inference optimization, and production AI deployment patterns. In this particular level, you're very close to the open source community. What are the different features CNCF team is working on? How can you implement Kubernetes Gateway API for a certain application? You also need strong coding skills or be able to understand what code your AI tool is writing, because you'll be integrating a lot of code directly into AI systems. The biggest shift at this level is ambiguity. Nobody hands you clean requirements. You are expected to understand messy requirements quickly, identify bottlenecks, and then ship solutions fast. Certifications to target. NVIDIA AI Infra certification, Databricks Generative AI certification, and there are a bunch of learning tracks across OpenAI, Anthropic, LangChain, MCP workflows, and other production AI systems. A day in life means debugging complex AI systems, understanding the network infrastructure, doing performance benchmarks across different models, integrating different AI tooling within workflows, working with customer engineering teams. And there's a lot of context switching between architecture and implementation. Since there's so much of responsibilities, the salaries are pretty great too. These are the salaries. Let's dive into our last level, level 7. It is the leadership and organizational architecture layer. You are responsible for infrastructure strategy, platform direction, and engineering not just teams but organizations at company level. The role names here are distinguished engineer, engineering manager, head of AI engineering, director of infrastructure, head of platform engineering, or VP of engineering. At this level, your decision impacts hundreds of engineers and millions in infrastructure spend. You're balancing reliability versus cost, standardization versus flexibility, and long term architecture versus business speed. So, a lot of your life revolves around business, how you can reduce the cloud spend, how you can do proper capacity planning, and how can you meet those business metrics. At this level, you are experimenting with different AI models, different toolings, different MCP integrations, and then integrating it into your team's workflows. Data privacy, AI governance, AI assisted engineering productivity, these are all the items in your bucket. Beyond cloud, you're very familiar with other AI native integrations and which one you can pick for your ecosystem. At this level, you're not really targeting any specific certifications unless you really want to dive into OpenAI track or Anthropic track or any other AI tooling track. And a key reason for that is also leadership outcomes matter more than certifications here. A day in the life means architecture reviews, executive meetings, EBCs, hiring, technical strategy, partnership with other companies, and long term planning. These are the salaries you can target. Now that's a wrap. So here's the biggest thing I want you to take away from these 7 levels. Do not skip the foundations. Not just because you are a level 1 engineer or level 2 engineer, even as a level 7 engineer, you need to understand what systems you're building on. Rather, it be understanding system design concepts at its core. Load balancing, caching, multi cluster, traffic distribution, those are still important. And every level compounds on top of the previous one. So, in summary, level 1 through level 4 are non negotiable fundamentals. And whatever you build on top of that in the next levels, it's just going to help you stand out and be that 0.1% of engineers. And final point about certifications, they help open doors in your career, but they don't create you as an architect or a forward deployed engineer. A certification without any specific system that you have built or a project you have worked on is just a paper. So always pair certifications with some real hands-on experience. So go figure out which level you are currently at. Firstly, be honest about it, what skills you need to brush in the current level and what skills you need to build for your next level, and then start working on it. So drop a comment telling me which level you are at and which one you are working towards. And if you need detailed guidance and resources for each of these levels, I've linked a guide below. Do check it out. See you in the next video.